Ever wondered what would happen if the world's largest ice sheet, Antarctica, just melted? It's a huge question, and honestly, even scientists don't have a single, clear answer. That might sound scary, but it's actually a fascinating look into just how complex our planet is. Today, we go into dive into why predicting Antarctica's future is one of the biggest challenges in climate science. So, let's get the big picture first. Antarctica holds about 90% of the world's ice. If all of it melted, global sea levels could rise by nearly 60 meters, or almost 200 feet. That's enough to redraw coastlines all over the globe. But the real question isn't if it could melt, but how fast. And that's where things get really tricky. You might see headlines giving different timelines. Some scientific models suggest it could take a couple of thousand years for a significant collapse. Others, however, point to much faster scenarios, maybe just a few centuries, even as little as 200 years, if certain tipping points are crossed. So why the huge difference? Why can't we just get one straight answer? Well, it all comes down to the incredibly complex dance between ice, rock, and ocean. Antarctica isn't just a simple block of ice sitting on land. It's a continent-sized collection of glaciers and massive ice shelves, which are the floating extensions of those glaciers. These ice shelves act like giant corks in a bottle, holding back the land-based ice from flowing into the sea. The main problem is that we're seeing these ice shelves get attacked from below. Warmer ocean water is seeping underneath them, melting them from the bottom up. This thinning makes them weaker and more likely to break apart. Once an ice shelf collapses, the glaciers behind it can accelerate, like taking your foot off the brake on a steep hill. Modeling this process is super difficult. We need to understand the precise shape of the seafloor beneath the ice, which is a massive area hidden under kilometers of ice and frigid water. We also need to map the ocean currents that carry warm water towards the continent. These currents aren't simple. They're like winding, underwater rivers that can change course. Then there's the ice itself. It doesn't just melt. It fractures, cracks, and calves off huge icebergs. One of the scariest processes is something called marine ice cliff instability. The idea is that if an ice shelf retreats past a certain point, it could expose incredibly tall ice cliffs at the water's edge. These cliffs could be so tall that they become structurally unstable under their own weight and just collapse, leading to a runaway retreat that's very hard to stop. Scientists are working incredibly hard to figure this all out. They use satellites to measure ice thickness, ships to map the ocean floor, and supercomputers to run simulations with all this data. Each new piece of information helps refine the models, but there are still huge unknowns. The difference between a 200-year timeline and a 2,000-year one depends on these tiny details in physics that we are still trying to fully grasp. So, when you hear different numbers about Antarctica's melt, it's not that the science is wrong, it's that the problem is just that monumentally complex. It's a reminder that we're dealing with powerful, interconnected systems. The uncertainty isn't a reason to relax. If anything, it's a reason for caution. It tells us that we might have less time than we think and that our actions today to reduce emissions are more critical than ever. What do you think is the most surprising part about Antarctica's future? Let me know down in the comments. Thanks so much for watching, and if you found this interesting, please consider subscribing for more deep dives into our amazing planet. See you next time.